Okay, when you factor integers, let's take a look at the vocabulary on your paper. Factor, to write a number is the product of numbers. So the first thing I have to know is if I have a product, the word product implies multiplication. Okay? We have to know what our vocabulary means. That's one of the most important parts about this class. If I say the product of two numbers is 6, then I know that I'm going to take two numbers, n times x is 6, the product of two numbers. Well, they look like two letters to you, but they are really representing two numbers, okay? So each one of these numbers, well, obviously I can put several different things in there. I could put 2 here for x and 3, or 2 for n and 3 for x. I could put 3 here and 2 here. I could put 1 and 6, 6 and 1. I can do 1/2 and 12, but I'm not going to get into fractions here. What I'm going to talk to you about is the fact that these numbers, each individual number is called a factor of 6. It's a factor of the number. In other words, the number is easily divided by its factors, evenly. Okay? So, and what we're going to talk about is the positive factors. We're not going to worry about negatives right now, okay? So what we're going to talk about is the factors of all these numbers on this page. So now number 1, list all of the positive factors of 10. Okay? So 10 is easily divided, every number is easily divided by itself and 1. Right? So those are the two easy ones. Right? I can divide this by 1, and I can divide it by 10. I can divide it by 2. Does anybody know what else I can divide it? 5. I can divide it by 5. Okay, anything else? No, right? Each one of these numbers is called a factor of 10. And that's how you list them. That's number 1. So if you're taking notes, you write down exactly what I wrote on the board, and you write down that I have listed all of the positive factors of 10. Now I know sometimes I talk a little faster than you can write, so if I do, just tell me to slow down. Okay? Number 3 is 36. If I want to list all of the positive factors of 36, okay, I can list them. Everything that goes into 36 evenly. Well, I know instantly that 1 and 36 go in there. All right? Put it away, Felix. Put it away. Oh, what are you doing? Oh, all right. Okay, 1 and 36 so far. So then we also have 2, because it's an even number, because you know your divisibility rules. Okay? Now, do you know the divisibility rules for 3? Do you know, Elise? What are they?
Anything that can be multiplied by 3, or, yeah, by 3 is divisible.
Well, I can multiply any number by 3.
Like, if it's like a multiple of 3.
If it's a multiple of 3. But how could you know if I wrote a number 1, 2, 7, 9, 8 and said, is that divisible by 3?
You have to add the numbers, and if it's the number is a multiple.
Exactly. I add the digits, don't I? Okay? So the digits here total, the digits are 3 plus 6, which is 9. Well, 9 is easily divisible by 3, so I know that this number is divisible by 3. Okay? Now, what about 4? Is it divisible by 4?
Yes.
Sure. It's divisible by 4 because 4 times 9 is 36. Is it divisible by 5?
No.
No, because the last digit does not end in 0 or 5, right? Okay, how about 6?
Yes.
Yes. Now you'll notice something about 6. 6 is kind of neat because 6 is actually the product of two other of the factors. So whenever the product of it, whenever this number is in your factor list, the product of its factors are going to be, those two factors will be in there also, okay? How about 7? What's next? 8? 9?
Yes.
Sure. 9 times 4. We already said that, right? So 9, I'll just get this one out of here. How about 10? See, what I'm doing is you have to go all the way up to the number. Sometimes if your number is large, this is like a lot of work, isn't it? Okay? 11. No, right? Because you know it would be 33 or 66 if it was divisible by 11, right? Okay. 12.
Yes.
Sure, because 3 and 4 are there, right? And 12 is there, okay? How about anything else? 13? No. 18. 18 is in there. 18 times 2. You see what's happening is every time you're dividing it by something here. So once I get down to the 2 times 18, I'm pretty much done, right? Because then I have 1 times 36. If you'll notice all those, they do pair up, okay? 2 and 18 pair up. 3 and 12 pair up. 4 and 9 pair up, right? 6 pairs up with itself because 6 times 6 is 36. Okay, so 36 is actually, for the future, is what we call a perfect square because a number multiplied by itself is equal to that number. Okay? So this is what you're listing, is you have 1, 2, 3, 4, 6, 9, 12, 18, 36, and you list all of those numbers on your paper. Okay? So you see how to do these. Now, let's talk about that. It says caution on your paper, factors come in pair. For example, since 12 divided by 3 is equal to 4, and 3 and 4 are both factors of 12. So you'll notice that they even say that factors come in pairs. Okay, so now they're going to list negative and positive. So you'll notice when they say list all pairs of factors, like in number 9, 9 has 11. Now, okay, 11 has itself and 1, right? Those are the factors. 1 times 11. If I multiply positive 1 times positive 11, I get positive 11. But I can also multiply negative 1 times negative 11 and get positive 11. So you see, the pairs of factors is a different set of directions. Okay? When it says list all of the positive factors of each number up above, we just want a list of all the factors, positive numbers. Now when you look at 9 through 23, you're actually listing all pairs of factors of each integer. So now you'll have 2 negatives make a positive and 2 positives make, okay? So, but they're not different. No, so number 11, 23. 23. They've chosen numbers that don't have a lot of factors here for you, so you don't have to write a lot of pairs, right? So 23 is divisible by 1 and 23. So your answer on your paper would be 1 times 23, comma, negative 1 times negative 23. Does anybody know what we call a number like 11 or 23?
No, prime number.
It's a prime number, isn't it? Okay. A prime number, which is a nice thing. Let's just go right on to the prime number definition. The prime number is a number that has exactly 2 factors. 1 and itself. Okay? 2 factors. Exactly. Now when I say the word exactly, That's exactly what I mean. It has no more, no less, and that's what exactly means. If I said, be here exactly at 12 o'clock, I want you here at 12 o'clock, right? I don't want you 1 minute after or 1 minute before. Okay? Now, time is one of those things people like to change around to suit their own means, but when a mathematics teacher says exactly 1, we mean there are no more or no less than 1, okay? Or exactly 2, okay? We mean that it has 2. So 11 is a prime number. Because it has exactly 2 factors. Okay, and that's exactly what a prime number is. Okay? So, let's take a look at number 13, 57. Now some of these you're going to want, if we have a negative number, let's take 57 first. Let's do one more. 57, okay? Is that divisible by anything?
Yes.
Yes. What?
3.
It's divisible by 3. It's divisible by 1, right?
57.
And it's divisible by 57. 3 times what is 57? The other number must go in there. Remember, they come in pairs. So you see the first part of these, 1 through 8, helps you to do 9 through 23, right? Because once you can list all the factors, now all of a sudden we can worry about the signs of the factors. Because when it says list all pairs of each factors of each integer, they're going to want you to take into consideration the sign, okay? 3 times what? 17, right?
19.
Wait a minute, is it 27 times 9 is 3, so it's 19. Do you know how I did that? You guys know how to divide quickly?
Yeah.
I mean, like divide in your head quickly? Okay, good. All right. Well, I think we've listed them all, and like I said, in this set of problems, there won't be as many in your list. That's not a decimal point here, it's just a 3. Okay, so now I need to get a positive. That means I have positive 1 times positive 3. Now, if you run out of room on your paper, just write 1 times 3, comma, negative 1 times negative 3. Whoops, I didn't mean to write that comma there. Okay. Then we can write what? Oh, I didn't mean to do 1 times 3. What am I doing? Just showing you how to do this.
It's a Monday morning.
I know, it's a Monday morning and I'm like not thinking here, right?
It's too early.
Okay. 1 times 57, right? 157. And I did it again. I drew the comma. 1 times 57, comma. Negative 1 times negative 57, comma. Then 3 times 19, right? So you're going to do the same thing. 3 times 19, negative 3 times negative 19. Okay, and that should fit on your line. Okay? Those are all the pairs of factors. So when we say a pair, we mean 2, like salt and pepper. Mr. and Mrs., that's a pair. Okay? That's 2. All right, now on the back side of this sheet, if you'll flip over, we're talking about find the prime factorization, and you'll see something that's very familiar to you all, which you call a prime factor tree. So number 25, we have 30, and we're going to divide it, and we're going to divide it by prime numbers. Okay? Now, first of all, 1 is not a prime number. Get that through your head. 1 is not prime.
Sweet.
Okay? Because it has exactly 1 factor, 1, right? It doesn't have exactly 2 factors. Okay? So take 30, and we're going to take this down, and we're going to tree it out. It's divisible by 2, right? 2 times 15. And 2 is just bring your 2 down. If you don't remember how to do this, 15 is divisible by, it's not divisible by 2, but it is divisible by 3. 3 times 5. And now I have a list of all prime factors, don't I? 5 has exactly 2 factors. 3 has exactly 2 factors, and 2 has exactly 2 factors. So I have all the prime factors of 30 except for itself. Okay, well, itself is not a prime number, it's a composite number. But 2 times, if I put a multiplication symbol here, I get 6 times 5. Okay, 2 times 3 is 6, times 5 is 30. Okay, you see how that works? Now, if I wanted to list all of the factors, I'd have to put 1 and 30 in also. But I wasn't asked that. Okay? So in this case, you're doing this as prime factorization. Now, if you have a larger number, let's take a larger number. Let me take another number like 388. That's another one on here, another one of the odds. Okay, what's this divisible by? First of all, it's divisible by 2, right? 2 times 150 plus 44. What's that? 194. Okay, and you bring the 2 down. 194 is also divisible by 2, right? So you get 2 times 97. And 97, is that divisible by anything?
Yes.
What?
That's the one that's divisible by 3.
No, it's not.
No, it's not divisible by 3, because 9 plus 7 is 16, and 16 isn't divisible by 3. Okay? Is it divisible by anything? I don't think so. 11, 12, 13. I'm looking at the prime numbers. The only ones that I would worry about would be 13 and 17 and 14. Well, 14 wouldn't go in because it's not an even number, right?
You can't put it in half, because then you'll end up with a decimal.
And, okay, well, let's just say we're at the bottom, okay? Now, how am I going to write this? I have 2 2's, right? So I really have 2 to the second power times 97, okay? And let's say that's the prime factorization, and because without my calculator, I don't know if 97 is prime. Now, on your calculators, by the way, you have an is prime function. If you have your calculator, your graphing calculator, it has a is prime. And you can determine whether something is prime, because some of these larger numbers, they're miserable to try to figure out if they're prime or not.
And that's what we have taken.
97?
I think it is, isn't it? Yeah. Okay, so what you're going to do is if you have multiples, like if I had 3 2's, I would have 2 to the third here. Okay? Now, this is what you called the factor tree when you were in elementary school, right? And you still do it that way, right? Okay, what gets confusing is, first of all, it takes up a lot of space. So I'm going to show you an alternative method of doing this, okay? Just because this is the way I learned how to do it. And it might make more sense to some of you. Okay, so let me take another one. Let's take number 33 is 180. Now if you think about division, that's really all I'm doing is I'm dividing this number by some number, some prime number, right? If you think about division, we normally draw our division sign like this, right? Well, I'm going to draw it upside down. I'm going to flip that thing over, and I'm going to draw it like this. And I'm going to put my divisor out here. I know 180 is divisible by 2, and I'm going to only use prime numbers out here. I'm going to start by dividing by the smallest numbers I can possibly find that go into it. That's how you start. That makes it easy. Because 2 times 90 is 180. Well, 90 is also divisible by 2, so I just come down like this. And 2 times 45. You'll find out that this makes it a little bit neater because all your prime factors will be found by going right straight down here in a straight line. What happens with the tree is you forget to carry something down again and again and again, and it's all crooked on your paper. All right? So this is the way I happen to like to do it. 45 is divisible by 5, right? 9. 9 times 5 is 45. 9 is divisible by 3, and 3. And 3 is divisible by 3, 1. Okay? I have all of the numbers that are prime factoring. All of these numbers right here is the prime factorization of 180, right straight down in a row. So I have 2 2's, so I do this. And if I want to list them smallest to largest, I would put the 3 next, 3 squared, and a 5 to the first power. You see how I did that? Okay? All right. And that's all you're doing. Now, the next section is finding the greatest common factor, the GCF. I know this is kind of a review, but GCF, greatest common factor. Okay. You already know what factor means. It's a number that goes into the number, right? It is a factor. A number that goes into the opposite of a prime is a composite. Composite number evenly. Okay? I call these the goes intos. Okay? It goes into that number evenly. Okay? Common, if something is common to things, it is in both of them. Okay? In both. So it's a number that goes into this composite number, but it also goes into both numbers, which implies, or all. So it either goes into both or all, which implies I have more than one number. Okay, so this is key because, why? Because before I was listing all the factors of one number. I listed all the positive factors of one number, and then I listed all the pairs of factors of one number. Now I'm going to look at 2 different numbers, and I'm going to evaluate what's the thing that they have in common. Okay? And it's the greatest, which means it's the largest. And I hate to use the word largest, and I hate to use the words large and small, because I can tell you right now, okay, this is larger than this. It's bigger than that. It is not greater than that. Okay? There's different things, okay? Large and big have to do with size. Size is a physical thing. That digit 2 is bigger than that digit 5, okay? But it is not greater than. Greater than has to do with the value of the digit, the value of the number, okay? Just so you know, that's a definition. Okay, so I really don't know what to tell you about greater than, other than it's greater than. Okay, you can think about it as bigger or larger. Okay, it's the greatest number we can get out of some number, that we can divide some number with. Now, how do we find this greatest common factor? Okay, let's take some numbers. We have to have 2 numbers to do this with, 28, 70. So they give us 28, 70. Okay? Now, this is pretty simple as far as that goes, but what I like to do with this is when you get difficult numbers, I like to do my prime factor. So do your prime factorization. So if I do the prime factoring of 28 and I divide it by 2, really simple here, I get, and when you get down to a 1, you have your prime factors here, right? So 2 times 2 times 7 equals 28. 70, done really quick here, is 2 times 5 times 7. Okay? Now my greatest common factor is they have to have something as great as, okay? They have to match. This is called the matching game, okay? We call this the matching game. They have to match in both factor lists. And what you do is you make a list of both the factors that match, okay? This number has a 2 in it, okay? This number has a 2 in it. So my greatest common factor has a 2 in it, okay? This number has another 2, but this one doesn't, so I can't use that 2. So that guy doesn't get used, okay? Well, this one has a 7 in it. Well, this one has a 7 in it, so I have to put a 7 up here. Well, this one's got a 5 in it, but that one doesn't have a 5, so I can't match it. Do you see what I just did? I matched. What was it? I matched all the factors that matched between both lists. Now I multiply them together. 2 times 7, 14. 14 is my greatest common factor. Okay, did I do that too fast? So you see, it was not 7. It wasn't the biggest number in your list. It wasn't the greatest number in your list. It was the matching numbers in your list, the product of the matching numbers in your factor list. Okay? It's a real simple way to do this. Now, you can also factor things on that fancy calculator you got by just typing in factor. Factor, give it a number. It'll give you the prime factorization. Does everybody have a fancy calculator?
Yes. It's at home.
Okay, charge them. Okay? Because when you do numbers in the thousands and things, it's a lot easier to just factor. Now, you do have to know how to factor some of the smaller things, okay? So let's take another one. Let's do some more. Because sometimes you can have 3 numbers that you're going to factor, okay? Let's take 108 and 180, 108 and 180. I'm going to separate them like this because I'm going to do it like this. If you want to do your trees, you can. 54, this is just, takes up a lot less room for me. 27, right? 27, which is divisible by 3, which is divisible by 3, which is divisible by 3. You always have to get down to 1. You start with your number and you end with 1. Then you get your prime factor list here. 2 times 2 times 3 times 3 times 3. And you start over here, okay? I don't have to tell you what I'm doing over here, right? And I ended with 1. I started with my number and I ended with 1. So I have this list right here. 2 times 2 times 3 times 3 times 5. And this is equal to 180. And this one over here is equal to 108. I should put that. Notice I've listed them right on top of each other. That was kind of cool, huh? Because now I can look, and if I list them largest, smallest, least to greatest here, like this, as I can match them up like this. So I have 2 2s, 2 3s, and I'm done matching pairs. I got to find pairs. So I have 2 times 2 times 3 times 3. You just list them all out. All your pairs, you list one of them out and multiply them together. 4 times 9 is 36. That's a 4 and that's a 9, right? 4 times 9. Okay? Does everybody see how I did that? Okay? And that's how you do these. Okay? Okay, should I do another one? All right, you good? Is everybody good on this? Everybody's gonna ace this one? All right. Let's do, so for homework, you're going to do the evens on this whole sheet, 2 through 42, okay? It's on your assignment list. So study guide 5.1 evens, and it's due tomorrow, 2 through 42, and you can get started right now.